Okay, so now let's talk about the most important topic, which I think is solving trig equations. So you're going to see this a lot in calculus. Sometimes you'll see it in engineering. Well, actually, most of the time you'll see it in engineering and a lot in physics as well. In chemistry, you also see it, especially when you go into physical chemistry. If you do quantum chemistry, you'll see a lot more trig functions as well. So how do we go ahead and solve a trig function? So let's just give you a little reminder. So if we wanted to find the equation cosine x equals 1/2, we would take the inverse to both sides. So we can take arc cosine to both sides. And you can see that the cosine inverse of 1/2, if you use your calculator, you might get pi over 3. But remember, cosine inverse has a restriction from 0 to pi. So you will only get the angle that is in pi over 3. That's in quadrant 1 or 2. So in order to find the other solution, well, we got to look at the unit circle. Okay, so here's where our unit circle is going to be really useful. So make sure that you either download a copy of the unit circle to be able to figure out what the rest of them are, because the calculator will only give you one. So the other solution is in quadrant 4. Why quadrant 4? Because remember that all students take calculus. So we got pi over 3 being one of the solutions in the first quadrant. The other one where it's positive 1/2 is down here. So this will also give you a solution which is actually going to be 5 pi over 3. So it's going to be two different types of solutions, okay? So let's say if we wanted the angles to be from 0 to 2 pi, then the answers will be pi over 3 and 5 pi over 3. So those will be the two solutions. Now, if we wanted all the solutions, because remember that if you look at the cosine curve looks like this. So you'll only get the one at 1/2 here and here. So let's say this is 1/2. Here's the angles that correspond to 1/2. But remember that that's just within one period. This guy continues to oscillate every 2 pi units. So what you're going to have to do is take the solution itself and add 2 pi k. And here k is any integer. So in other words, if you wanted all the solutions, then you would write pi over 3 plus 2 pi k, or 5 pi over 3 plus 2 pi k. So this will go ahead and give you all the solutions. Now, sometimes the k can be substituted with an n. Okay, so it really just depends on what they want. So in the homework, if they want k or they want n, just take note of it. What do they want? For this particular problem, we're going to use k. All right. All right. So if you want the solutions within an interval, make sure that you either look at the unit circle or use reference angles to find the remaining solutions. Okay. So let's go ahead and do a whole bunch of different examples. So let's go ahead and take a look at this equation. So solve the equation sine t equals 1/2. So we want to have the two solutions, one from the interval from 0 to 2 pi and one for all the solutions. Okay, so one way that you can do this is you can take sine inverse, but because we only want 0 to 2 pi, it's better to just look at the unit circle. So I'm going to look at the unit circle. If you have your own unit circle, you can take a look at it. So what we're looking at is where exactly is the sine equal to 1/2. So you'll see that it's positive 1/2, so you'll have solutions in quadrant 1 and quadrant 2. So it's going to be 1/2 here, which is equals pi over 6. And it's also going to be a solution here, which is going to be 5 pi over 6. So my answer would be t equals pi over 6 and 5 pi over 6. So this would be my solution. Now, what about all solutions? Now, for all solutions, all we really got to do is just write plus 2 pi k. So basically, pi over 6, add another 360 degrees, and you can do it any multiple number of times. That's what the k means. And also 5 pi over 6 plus 2 pi k. This will be my other solution. So this will be all the solutions. This will be the solutions within just 0 to 2 pi. Okay, so let's do a couple more examples. So let's solve this equation in the interval from 0 to 2 pi. So basically, we don't want the 2 pi k. So I'm going to go ahead and solve for sine, because we're going to isolate it. So I'm going to move the 1 over. So we're going to get 2 sine x equals -1. I'm going to divide by 2. And I'm going to get that the sine of x is equal to -1/2. So now what I got to look at is where exactly is the sine going to be negative 1/2. So negative 1/2 is going to happen somewhere over here, which is going to be at 7 pi over 6. And also out here, which is going to be 11 pi over 6. Because we only wanted the interval from 0 to 2 pi, we're not going to add 2 pi k. So we're going to write x is equal to 7 pi over 6 and 11 pi over 6. Now you have to be very careful, because if you end up using the calculator, I want you to go into your calculator and put sine inverse of negative 1/2. So if you go into your calculator and write sine inverse, what you'll end up getting is something weird. So you'll end up getting negative pi over 6, which makes sense because remember that our arc cosine only is restricted between negative pi over 2 and pi over 2. So what you're getting here is the negative angle, which is a negative pi over 6. If you wanted to get the positive angle, all you got to do is just add 2 pi and you'll get that 11 pi over 6. So always remember that you want to make sure that your interval is from 0 to 2 pi. So we do not want any negative values. Even though this is a solution, it will not be the correct solution. So you have to make sure that you follow directions. All right, so now let's go ahead and take a look at the next example. So again, we want the interval from 0 to 2 pi. Let's look at secant. Cosecant theta equals negative 2. I don't like looking at cosecant instead of like looking at sine. So I'm going to use the reciprocal identities. I write 1 over sine theta equals negative 2. So I can move the sine theta over. So I get negative 2 sine theta. And then divide by negative 2. So you get that sine theta is equal to negative 1/2. And you can see this is exactly the same problem as before. So theta is going to be equal to 7 pi over 6 and 11 pi over 6. Okay, so those are going to be the solutions for this problem. Okay, so I like to look, whenever I have secant, cosecant, or sometimes even cotangent, I like to write them as, the opposites of those, the reciprocals. So now let's look at this one. Secant squared equals 4. Let's go ahead and get rid of that squared. So what I'm going to do is I'm going to take the square root to both sides. So secant squared x equals 4. What I'm going to do is square root both sides. Add plus or minus. Don't forget that that's super crucial. And secant x equals plus or minus 2. Now remember, looking for secant can be a little complex. So let's make this into 1 over cosine of x. I'm going to move the cosine over, so I'm going to have 1 equals plus or minus 2 cosine of x, and then divide by this plus or minus 2. So you end up getting that cosine of x equals plus or minus 1/2. So what we're looking at in the unit circle is looking at where exactly is the cosine of x equal to positive and negative 1/2. So it's going to be 1/2 around here, 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 and here. So if you look at the unit circle, you'll have 1 at pi over 3. That's where it's positive 1/2. Then it's negative 1/2 at 2 pi over 3. It's negative 1/2 at 4 pi over 3. And it's also positive 1/2 at, what would this be, 5 pi over 3. So when I write my solutions, x is going to be all of these. 2 pi over 3. Oops, that's wrong. Pi over 3 first. 2 pi over 3, 4 pi over 3, and then 5 pi over 3. So these are 4 solutions. And the reason why we had 4 solutions, it makes sense because there was a plus or minus there. Okay, now let's take a look at these types of problems, because these problems can be a little tricky. So notice that negative 0.4 is not in the unit circle. So that means we have to go into our calculator now. So what we have to do is, let's take cosine inverse. So we want all solutions. So we need to add up 2 plus 2 pi k stuff. All right. So let's first start off by taking the cosine inverse. Okay. And let's set this to radians. So let's go ahead and take a look at what that is. So I'm going to go into my calculator and put cosine inverse of negative 0.4. And what you're going to end up getting is 1.98, about there. Now remember, there's two values because the cosine will be negative in two different quadrants. So if you remember, all students take calculus. So the cosine x is equal to negative 0.4. So that's negative, which means that that value should have been wherever the value is negative itself. So the value is negative somewhere around here. So it must have been around here. Let's just say this here. Okay, so that's where the cosine is negative, and the cosine is negative down here as well. Okay. So here is our angle. So our angle that it makes from here to here is just going to be 1.98. Okay, that's the angle that it makes. This is the angle. Now the question here is we need to figure out what exactly is going to be the angle here. Okay, so we need to figure out what exactly that guy is. So here's where you got to do a little bit of geometry. So this angle here, let me color it a little different. So this angle here is exactly the same angle as this guy. All right, so I know this is 1.98. Let's try to figure out what this angle is. So I know this is 180 degrees. This is pi. Okay, so if I want to figure out what this leftover part is, well, I'm going to do pi minus 1.98. And that's going to give me that red part there. So let's do pi minus 1.98. That's going to give me 1.16. So that means this guy right here is 1.16. If this guy is 1.16, that means that this guy should also be 1.16. So how could I possibly get this angle down here? Well, I already know that this whole thing is pi units. So I have pi. So what I'm going to do is take pi and add this 1.16. So I'm going to take pi and I'm going to add 1.16. And that's going to give me my second answer. So I'm going to take pi, add 1.16, and I'm going to get 4.30. So my answers, remember I want all solutions, it's going to be 1.98, which is this guy. Here's 1.98. So it's 1.98, and if I add another 2 pi radians, I'm going to get the next value. And my other one is going to be this other one, 4.32, or 4.30. And then if I add another 2 pi, okay, I'm going to get the next one. So these two will be my answers. So here you have to do a little bit of geometry to really make sure that you know what you're doing. Okay, let's take a look at this guy, 2 sine x. So I'm going to divide by 2. So I get sine x is equal to 0. Again, we're looking for all solutions. Okay, so we got to think about where exactly is sine of x equal to 0. Well, sine of x, in this case, if you think about the quadrantal angles, sine is going to be 0 here at theta, well, let's write x. At x equals 0, let me just write theta. At theta equals 0, and also at theta equals pi. That's when it equals 0. And we want all solutions, okay? So the answers are 0 and pi. So let's take a look at this. So this so there's 2 ways that you can do this. One way that you can do it is you can write x equals 0 plus 2 pi k, and then pi plus 2 pi k. But notice that, can I just make this, instead of writing it as 2 different solutions, it's better to write it as one whole solution, because you can see from here to here it's only pi units. And then I go back every pi units. So it's better to just write 0 plus pi k instead, because this simplifies the amount of terms that I gotta do. So instead of rewriting this, is kind of redundant, I'd rather just do 0 plus pi k, and that will iterate through all the different solutions here. Okay, so this would be our answer. So this is the one that I would prefer. If you end up doing this one, I guess it's okay. But yeah, this one's the one that I would prefer. Okay, so that's it for these types of problems. We'll do some tangent and cotangent in the next video.